Hello guys. Today I'm going to present something that most of you are familiar with, which is AOP in general and how we apply that to Mule, but I hope that we can go a bit more in depth, more than what you already know about this. So first, for whoever doesn't know what AOP is, aspect-oriented programming, the history behind this, how it was started, was to have cross-cut concerns across applications. So one of these cross-cut concerns is security. If you have your own services and you have the service for listing users and another service for listing addresses, and you want to add security, let's say whether to check if a user is authenticated to execute that or not, you have two options. Either you call, the regular option is to call this authentication service or whatever mechanism you have in each of these services, right? Which adds some noise to the actual logic, because if you want to list addresses or list users, you are not caring that much in that business logic about that. And the other option is using aspect-oriented programming, which is a way to configure these services and to tell, not within the service itself, but rather within the wiring that you are having for your configuration. You tell them to these bins, you apply this aspect. So what it will do then is you will have to code your logic in there and then configure outside whatever aspects you want to add. In this case, it will be the aspect of security. Another usage is for logging. So that way you have your logic that is not mixed or contaminated, let's say, by this side logic, which is called aspect. So that is why it was born. I also named a few cases that are related to this. And going into the way that Spring approaches this, Spring has what is called advices and point cut. A point cut is a predicate. It's a predicate that tells the configuration what method or what class you want to intercept. It's quite powerful. You can intercept, for instance, you can intercept all the classes that are within a package, classes with a certain name. You can intercept a method that receives a certain group of parameters or returns a certain type. So it's quite powerful. It has a language of expressions where you can use to configure this and intercept either a family of methods, a family of classes, or a particular class, or a particular method, or a combination of both, a particular method in a particular class. If you see my screen now, this is something that I forgot to mention before, which is the way that Spring approaches these point cuts. So you have in the first line of the graph, let's say you have the class X that has methods A and B. This is a regular class. So the way that Spring approaches this by default is to use a proxy for this concrete class and proxy these methods. So whatever you call any of these methods, you will have a Spring intercepting that to a proxy. So when you apply this AOP configuration through Spring in Mule, what you actually start having are proxies of these objects that for every client object calling this object, they will think that they are calling the actual object, but they are actually calling the proxy object, which is already wrapped with the aspects. Well, here you have a configuration, but let's go to actually execute this. Let's see this in action. The way that Mule has this configuration is first, this is done, as I was mentioning, with Spring in Mule. Here you have 3 key parts. I'm not going to follow each line, so it's easier to understand. The first line is a point cut. what I was mentioning before is the predicate that will intercept this. This has an expression where you tell what you want to intercept, as I was mentioning, a family of methods, a particular method. Then you have the point cuts. So these point cuts are, you have basically the 3 point cuts that are that you might be using: before, around, and after. Before is a point cut that gets executed before the actual method is called. Around is the most powerful one. This one is the method itself. So with this is so powerful that you could even change the return method that is being executed. And then you have the after, that it was after the method was executed. And then the third part is the advice. The advice is the actual class where you have configured the logic that you want to execute through the point cuts. So basically, this class that is called my advice that you are seeing here will have a method before and a method after. And another thing worth mentioning is that this is called before, but this method here, the one that is there, belongs to the class and can have any name. I just named them with the same name, but this could be called any other name. It doesn't have to be called before. So the way that this is typed is, here you have the aspect with the point cut, and with the point cuts, the methods that will be executed for those point cuts, and this is linked to the aspect. And this whole configuration represents the full configuration for the aspect. So if we take a look at this configuration, you will see that by reading this, what I want to do is to intercept the method called process within the interface called transformer. This is just a practical demonstration. It's for demo purposes, but if this done in the real world, let's say, you can intercept flows. For instance, we already have server notifications, but let's say that you want to do it some other way. You can intercept a flow when it's being executed and log when it started with the before, and when the flow was finished with the after. So you could do that. And here I'm using the transformer to show, to demo that, but in real use cases, you may imagine the applications that this may have. So going to the class implementation itself, you will see the methods here. The before is just logging. It's just logging the join point. The join point is the actual object that has the information of what is the point cut, what is being executed, what are the target objects. It's what is used to communicate with Spring and the actual execution. This is a bit more complex, so I will go after in detail about this, and then we have the after. So now, if you want to see this in action, we will start this application. And we will call this method, this endpoint. And then you will see the return I'm getting is just a collection with A and B, which is what I'm setting as a payload here. I have an object to string transformer. I added this transformer actually to make a call, otherwise you wouldn't see anything. And then you will see in the logs the before, right? What you see here, if we go back to the classes, I'm running the join point itself. This is the join point. It's basically telling you this is the expression that we had before and applied to what method with what return type. So this means that this is applying the method process which receives a Mule event and returns a Mule event in the object to stream object, which is an actual Spring object, the one that we saw down here, right? And also, as you can see, it's executing the after, the before and the after, which are the ones that I have configured. So let's say if I simply comment this and I run it again, you will see that now you will have only the before being executed because I removed the configuration for the after pointer. Here you see the logs, only you have the before. So having mentioned that, now let's comment the around one, which I told you that is a bit powerful. It's more powerful than the rest. The other methods is more to observe what the method is doing. But if you want to change any logic, let's say that with the example I was mentioning before, the user is not authorized to execute a certain method, then you will check that user executed, and then if the user can, you execute, you allow the aspect to do whatever it has to do. Otherwise, you return an error message, throw an exception or whatever. You will see this. You can see this in the code here. So what I'm doing here basically is I'm logging again that the endpoint is being logged, and then I'm changing the payload when I executed the transformer to a hard-coded one, which is 1, 2, 3, that you can see here. So the point that I wanted to show here is how you can alter the for instance, the response or whatever you need in the method with your own logic. This is quite trivial because it's hard-coded, but it shows you can add any logic, real logic for this. So now that I have uncommented that, I will run it again, and what we expect to see now as the return is 1, 2, 3, right? Instead of the collection that we saw before. And here you can see, right? We logged again that it was the around, and you can see that the return payload is different, and is the one that I modified here. So you can imagine how powerful this is, right? You can add the logic as I was mentioning, and change this with any required logic that you may have. This is the around. Any question about this?
Yeah, one quick one. The around method return should always match the actual method that you are.
Yes,
right?
yes, exactly. Something that that's a good point. Something that I forgot to mention here is that this is not breaking because with the expression, I'm intercepting only this particular method, right? But let's do this. Yes, this should break because it will intercept every method in the transformer.
But then there you would probably call the process, right?
You see?
Oh, it failed because your implementation doesn't have enough core methods to match all the ones that are.
No, what happens here is that you can see it's trying to cast default Mule context to Mule event. And why is this? It's because now it's intercepting every method, right? Not only the process. So even an initialize. So maybe the initialize or any other method is having a different target, and it's executing a different method. So that's why it fails. It didn't fail before because I was constraining.
But in that case, you create other methods with the same name, like before and around, but with different signatures. So you can match every method that is defined that is found by that pattern. Should be fine. Because you will automatically match the appropriate method.
I would need to check that. I'm not sure if it goes by signature, because what you are actually setting here in the
you're
address.
In there,
no, actually you can.
There you're saying just before, right?
Yes.
You can define like 3 or 4 before to match every.
Yes,
method.
but you are supposing that it will be intelligent enough to go and look for the one to use a matching. Yes, but I cannot assure that it will do it. However, here you have a configuration that is the argument names.
Okay, so you can expect just to make sure that the names of those attributes.
Yes. Yes, but I mean, if you have two options here, right? Because on the one hand, it's not likely that you will want to have a lot of before methods within a same an implementation for an advice. So I will design it in a different way that I will have different. However, if you have that, it will be a matter to see if it can read the overloaded method, to see if it can intelligently and automatically resolve that.
Yeah,
Other than that,
in any case, that will be only for the RAM, right? So
no, it can be for any method. Yes, for every method.
You are not returning anything.
Yes, but even if you are not returning, here is not the problem is not returning. Returning because it's the method itself that we will be calling. Even if the before is a void here, right? But it could be returning the same object without any changes. So you're not forced to have a void method in here. You can have, for instance, a string in here. But the thing is that it will try to match the object, I mean the return type in there with the actual object that it's trying to return. So if it fails to do that, it will break. What we are seeing now is failing because of this class cast in here, this casting in here. Because the configuration that I had before always was returning in event because it was a single method. Now it's intercepting every method. So let's put a break on here. Actually, it should be somewhere here. Yes, here. It's trying to do a dispose on object string. That's why it's failing. So you can debug this and see what method. That's what happened, and that's why I constrained it and I used this the process expression to avoid that. But something that you could also do is to leave this generic for every method, and then in the class itself add the logic. And then if check what is the method, what is the you could return object.
Yeah.
You can use the signature object and return whatever you need, but you will have to add some logic here. If showing point dot I think it was target is the object is yes, it's this is of a certain class, then I do this stuff. It's a bit more cumbersome than rather configuring the actual expression. You're welcome. Something that is worth mentioning in here is here are the limitations. You might be tempted to intercept anything in Mule, right? Here, not only a transformer, but for instance, to try to intercept an inbound endpoint. You may feel tempted that, but the limitation is that this cannot, since it's provided by Spring, it has to be a Spring object. And inbound endpoints are generated by Mule itself by instantiating a class, so it's not Spring instantiating the object. So it's because when Spring is actually instantiating this object, it's creating the proxy and doing all the configuration that you set in there. So if it's not managed, the life cycle of the object is not managed by Spring, you won't be able to use aspects. So that is the limitation that you have.
So you cannot intercept any object, right? You won't be able to do that.
No, you can intercept anything that is created to Spring, which is a bit tricky in Mule because there are things that are created as a Spring beans, flows, transformers like this, any Spring bean that you define with the Spring configuration, the configuration for DevKit connectors, those are Spring. So basically, it's anything that was created by Spring, and that would be able. The tip that I can give you here to understand whether an object is managed by Spring or not, what I do is to put the breakpoint in the constructor of the object. If it doesn't have a constructor in any property when it's being set, put that in debug mode and see who is creating that object. If I see that stack trace is a Spring, okay, fine, I can use aspect. If I see that it's doing a new instance, then you cannot.